Hello and welcome. In this video, we will learn how to simplify the grammar. Many times there would be unnecessary productions in the grammar that will increase the complexity. And due to that, we might have to do lots of backtracking and that will make the string acceptance process very slow. So if we can simplify the grammar, then that will become a shorter grammar and we can have a faster process to recognize the string. To simplify the grammar, basically we have to follow three steps. We have to remove all the useless symbols. We have to remove all the epsilon productions and we have to remove unit productions. To remove the useless symbols, we have two steps. Either we can generate non-generating symbols and we have to generate all non-reachable symbols. So in this particular video, we will learn about how to remove useless symbols. And for that, we will discuss both the approach, how to remove non-generating symbols, how to remove non-reachable symbols. So let us first start with removing non-generating symbols. What is non-generating symbol? Symbol X is said to be generating if, using grammar G, X derives some string W. So W is a string, so all the symbols in W must be terminal symbols. So W could be either epsilon or it could be string of length 1, 2, 3, anything. And X may not be directly having production X gives W. Rather, X might be deriving string W through some steps. But somehow, if X is able to derive some string, then we can say that X is generating symbol. Consider the grammar. Here we have three symbols, capital S, capital A, capital B. And as we can see that S derives small a. So small a is a W or it's a string in which all symbols are terminal symbols. So we can say that S is generating at least one string and hence S is generating symbol. Similarly for production A, there is A gives A production is there. So we can say that A is generating a string small a and hence A is also generating symbol because capital A is able to produce at least one string. But if we look at the production of capital B, then capital B gives capital B small b. So we have a sentential form on right hand side and in no way capital B can derive string. And that is why we can say that B is non-generating symbol because it is not generating any string and such symbols or such productions we should remove from the grammar. So grammar would be simplified. Algorithm for finding non-generating symbols. As a first step, every terminal symbol is generating because terminal symbols are string itself. So all the terminal symbols are generating. For every production, A derives alpha. If every symbol in alpha is generating, then A is generating. So that's very obvious that alpha is a collection of symbols. And if all symbols are terminal, then alpha is a string itself. And hence, the symbol capital A would be also generating because capital A is able to derive some string. Consider the example. We have to find a non-generating symbol out of this. So as a step one, we know that every terminal symbol is generating. So in this particular production, we have two generating symbols or two terminal symbols, that is small a and small b. So initially, our generating symbol set contains two symbols, small a, small b. Now we have to check if any production is of the form A derives alpha and if all the symbols in alpha are generating, then capital A is also generating, right? So one by one we have to check all the productions and we have to check if right hand side is string, then left hand side of that production, that is the symbol, would be generating symbol. If we look at the last two productions, then capital A derives small a. So here right hand side of A contains all terminal symbols or we can say all generating symbols and hence A is also generating. In last production, C derives B. So C is also able to generate some string B. B is generating symbol and hence capital C is also generating. So now our generating symbol set contains four symbols, small a, small b, capital A, capital C. If we look at the first production, S gives AB. So A is generating but capital B is yet not known whether it is generating or not. So from S derives AB, we cannot say S is generating. But for the production S derives CA, capital C is also generating, capital A is also generating and hence capital S is also generating. So that is what the next step. And now our generating symbol set would be small a, small b, capital A, capital C, capital S. Let us now check for capital B whether it is generating or not. For the production, capital B derives capital BC. So C is generating, but B is yet not known. So we cannot say B is generating. Then let us check for the second production of the B, that is B derives capital A, capital B. So again capital A is generating, but we don't have any idea about capital B because it is not part of generating symbol. So ultimately B is not generating, and hence we should remove the production of B from the grammar. Okay? So non-generating symbol is B. So our simplified grammar would be just 3 production of S, A and C. Delete all the productions starting with capital B. So you see that 2 productions are now removed. And C derives A capital B production was there. That has also been removed. And S derives capital A, B is also removed because B is non-generating. So anyway, using those 2 productions, we cannot have any string derivable. Another example, we have to find non-generating symbols out of that. So first rule says that all terminal symbols are generating symbol. So in this grammar, we have 2 generating symbols or 2 terminal symbols, small a and small b. From step 2, we will check all the productions of the form A derives alpha. If all the symbols in alpha are generating, then capital A is also generating. So if we look at the production number 3, C derives ABB. So all 3 symbols on right hand side of the production of C are generating, and hence C is also generating. So now our generating symbol set would be A, B, C. If we look at the production A derives BCC, then B is also generating, C is also generating. So all the symbols on right hand side of production A derives BCC are generating, and hence capital A is also generating. So our generating symbol set would be now A, B, capital A, capital C. Again, if we repeat the same process for production 1, then there is a S derives A, capital A, A. So small a is also in generating set, capital A is also in generating set. So all the symbols on right hand side of the first production are generating, and hence S is also generating. So our generating symbol set would be now A, B, capital A, capital C, capital S. Let us check it for the last production, that is capital E. E derives small a, capital C. Small a is also in generating symbol set. Capital C is also in generating symbol set, and hence E is also generating. So all 4 symbols, capital S, capital A, capital C, capital E are in generating symbol sets, and hence none of the productions will be removed. All productions must be maintained because they all are generating symbols. Many times we need to understand the order, because if we consider the first production, initially it may not be generating. But when we explore the later productions, probably after some times the production 1 might become the generating. So this is a recursive process. We have to keep exploring all until we are sure that okay, none of the production is now left for the checking. Second one is, to simplify the grammar, we have to remove non-reachable symbols. So let us first understand what non-reachable symbol is. Symbol X is reachable if it can be reached from the start symbol capital S. That is, symbol X is reachable if we have some production S derives alpha. Now S derives alpha may be direct production or it may be derived through some steps. But if that alpha contains capital X, then we can say that X is reachable from start state capital S. Again, if we can reach to any symbol X from the starting production capital S, then X is reachable symbol, otherwise it is not. So how to find it? For that we need to draw dependency graph, and dependency graph will tell us which symbols are reachable and which are not. X is said to be dependent on S if S derives alpha 1, capital X, alpha 2. So we can say that somehow we are able to reach to capital X from capital S. So here capital X depends on S. If S is not there, we cannot reach to capital X. So X depends on S. So if we have such productions of the form S derives capital X, then we have to add this kind of nodes and arc into the dependency graph, where left hand side of the production would be on left side, and right hand side of the production symbol should be on right hand side. So we are putting S and X like this, and on arc we have to write down the production. So we will write S derives alpha 1, capital X, A2, alpha 2. So that says that X is depending on capital S. X is not reachable if there is no path from S to X in graph. So we have to add all the productions in this dependency graph, and once all productions are added, we have to check which are the symbols reachable from capital S. If they are not reachable from capital S, they are non-reachable, and then we should delete it from the simplified grammar or the final grammar. Let us try to understand with the help of example. So for this grammar, we will start drawing dependency graphs. So first production says S gives small a, capital A, small a. So here on left hand side it's a capital S, on right hand side it's a capital A. So we will add the partial graph like this. S derives capital A, or we can say capital A depends on capital S, or we can say we can reach from capital S to capital A via the production S gives small a, capital A, small a. From capital A, we have two production. A derives SB, means from A, if we read SB, then we are moving to state S, right? Because A is now on left hand side. So left hand side should be originating vertex, and right hand side of the production should be the destination vertex. So A derives SB will lead us from capital A to capital S. Then for A, we have another production, that is A derives BCC. So we only have to look for the capital letters. Okay? So A derives capital C, or we can say that from A, if we read BCC, then we are moving to state capital C. So as A on left hand side, that should be originating vertex. Capital C is on right hand side of the production, so that should be the terminating vertex. So it looks like this. Next production is C gives ABB. Now here we have all terminal symbols on right hand side of the C. So we don't have to do anything, because right now we are interested in symbols only, non-terminal symbols only. So there will not be any arc for third production. Next, E gives AC. So from E, we can move to state capital C by reading AC. So as E is on left hand side of the production, it should be originating vertex. So from E, we have to draw arrow towards C, and that we can reach from by reading the production E gives A capital C. Now all productions are drawn. Now we have to check which are the states are reachable from capital S. So we can move from capital S to A. So A is reachable. We can also move from capital S to capital C via A, and hence capital C is also reachable. But there is no way we can reach from capital S to capital E, and hence E is not reachable symbol. And when we simplify the grammar, we have to remove all such non-reachable symbols, and our simplified grammar will look like this. We have to remove all the productions starting with E or involving E. The another example, we have to eliminate non-reachable symbols for this grammar. So again, S derives A capital B A. So we will move from S to state B by reading A B A. So S will be the originating vertex, B will be the terminating vertex. We also have one more production from S, that is S gives capital B capital C. So by reading that production also, we can go to the B or C, we can write anyone. So we will write S gives BC. Right? By reading this production, we are able to go to the state C. We can also write the same production for S gives BC as well. We can write on both the arc the same production, because both are leading to the state B and C. From A, if we read AC, then we are moving to state C. So we are adding this from A. If we read AC, then we are going to state C. And we also have production A derives BCC. So if we read BCC from A, we are going to state B, because there is a capital B involved into that. Now A derives BCC, we can write for this first arc as well, because instead of A derives AC, because this production also includes capital C. So that is okay. You can write down any one production, that is sufficient. Next, B gives small b, capital C, capital C. So from B, we can move to capital C state just by reading BCC. Then we have a production of the form C gives alpha A, but A is a string of terminals, so we don't have to draw any arc for that. Then D derives E. So from D, we are going to E. By reading the production, D gives E. And E derives D. Again, D is all the terminal symbols, so we don't have to put any arc for this. So this is the final dependency graph. If we check carefully, from S, we can go to B. From S we can go to C, but from S we are not able to go to capital A, capital D or capital E. So these three states are non-reachable symbols, and hence the production starting from those symbols we should remove. So our simplified grammar will simply look like this. So instead of 6 productions, now we have only 3 productions. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.